While the the core of the solar nebula was gravitationally collapsing to form the proto-sun and then the sun, in the outer regions of the protoplanetary disk, all those dust grains that we talked about earlier were drifting along, and occasionally, from time to time, they would bump into each other just by random chance. And when that happened, they would actually stick together as a result of static electricity, the same electromagnetic force that holds your socks to your sweaters when they come out of the dryer. And so what would happen is that these chunks of rocky material would get a little bit bigger, and then a little bit bigger, and then a little bit bigger in a process we call accretion, which is the accumulation of larger objects from the collection, from the combination of smaller objects. Okay? So here are these dust grains that are drifting through space, and again, occasionally they're going to run into each other, stick by static electrical forces, and what you end up with are slightly larger particles that can become larger and larger and larger. And this is important. Although this is a random process that takes millions of years, eventually these chunks will get big enough that they now have enough mass that their gravitational force becomes strong enough to pull in more material. So now it's no longer a matter of random chance. Watch as this object starts to pull in objects. They're not just drifting by and running into each other, but gravity is actually pulling them in. And the more massive the object gets, the more gravity it has, and the faster it starts to pull in material until you can build up larger chunks that we call planetesimals. This is an example of a positive feedback loop. We talked early in the course about negative and positive feedbacks, and remember, in a positive feedback, the process actually reinforces itself in this runaway effect. So here, when these objects get more mass because they've pulled in more materials, they now have more gravity. Having more gravity allows them to pull in more chunks. You get more accretion, which gives them more mass, which gives them more gravity, which gives them more accretion, and you get this runaway process where these planetesimals can keep colliding and building until you end up with what we call protoplanets. We think there were originally about 100 protoplanets flying around in the solar system. Now, needless to say, with 100 protoplanets, the collisions will continue. And these protoplanets run into each other, and the survivors of these 100 protoplanets and their collisions are the 8 planets that we see today. This idea of collisions between protoplanets explains a lot of observational features of the solar system. For example, it explains why every planet has an axial tilt, because these collisions would have knocked them a little bit over to the side depending on how big the collisions were. In fact, we